Ever find yourself scrolling through social media and wonder how the algorithm seems to know exactly what to show you? Or maybe you followed a recipe super carefully only to realize, oops, missed a step.
It's amazing how these, hidden instructions shape so much of our digital lives, isn't it?
Totally. And that's what we're diving into today, algorithms. But here's the twist. We're using a unique
Oh,
source.
this is going to be interesting. What is it? A dusty old computer manual.
Even better, we're cracking open a Malaysian secondary school computer science textbook. It's called Ask Tingkatan 1BAB3.pdf.
A secondary school textbook. Wow, that's a unique choice. I'm curious to see how they break down this complex topic.
Right, and what's fascinating is how this book makes it relatable, even if you're not a tech whiz.
That's the key, right? Making these concepts accessible. So let's start with the basics. What exactly do we mean by algorithm?
Okay, so we hear this word algorithm everywhere, right? Especially when we're talking about tech and the internet. But what does it actually mean?
At its core, an algorithm is basically a set of instructions to achieve a specific goal. It's like a recipe, but instead of baking a cake, you're, say, solving a problem or completing a task.
Okay, so like a roadmap to get from point A to point B.
Exactly. But just like a good roadmap, it needs clarity, precision, and the right order.
Right, because if you miss a turn, you might end up totally lost.
And speaking of order, this textbook has a pretty funny example about getting dressed.
Oh, yeah, I remember that one. It talks about putting on your shoes before your socks, right? Exactly. And it highlights how even a slight change in the sequence can lead to, well, let's just say, some interesting results.
It emphasizes how crucial that order is in algorithms. It's like one small misstep can totally throw off the whole process. Now, the textbook dives into some core elements of algorithms. Would you mind walking me through them?
Of course. So one of the first things they emphasize is clear instructions, right? You can't have any ambiguity.
Yeah, absolutely. Every single step needs to be super precise. No room for interpretation. This way, anyone or anything, even a computer, can follow it and get the same result.
So no vague instructions like add a pinch of salt that you see in some recipes.
Right. In algorithms, precision is key. Like they use the example of a scientific calculator.
Oh, interesting. How so?
Even for a simple calculation, you need to hit the buttons in a specific order, right? Each button press is carefully defined to get that accurate result.
That makes a lot of sense. And this leads to another important concept, finiteness, right? An algorithm can't just keep running forever.
Precisely. It has to have a defined endpoint. Like a destination on that roadmap. You don't want to keep driving in circles. The textbook really emphasizes that an algorithm needs to deliver a solution.
So it's about taking maybe a complex task and breaking it down into manageable steps.
Exactly. And to help visualize these steps, the textbook introduces flowcharts and pseudocode.
Okay, I've heard of flowcharts, but pseudocode, that sounds kind of intimidating.
It's not as scary as it sounds, I promise. Flowcharts use, different shapes and arrows to visually show how the algorithm flows, like a visual guide.
Got it. So what about pseudocode?
Think of it as a bridge between how we think and how computers think. It's a simplified way of writing code that's easy for us humans to understand.
Ah, so it's like a common language between us and the machines.
Exactly. It helps us translate those complex ideas into something more manageable. And to break things down even further, the textbook dives into control structures. These are basically the building blocks of algorithms.
Control structures, that sounds interesting. Can you tell me more about those?
Sure. Control structures are all about how algorithms make decisions and repeat tasks. They're what make algorithms smart, you could say. They introduce the concepts of selection control and repetition control, which we can dive into.
Decision-making and repetition. Those sound like pretty big ideas, not just for computers, but for life in general.
Absolutely. And the textbook actually makes a really good connection with everyday stuff. It talks about selection control, which is all about making choices based on certain conditions.
Okay, so like if this, then that kind of thing.
Exactly. They use this example of figuring out a student's grade. Like if the student gets above a certain score, then they pass.
Oh, right. And elsewhere, they maybe need to study a bit more.
Exactly. It shows how algorithms use those conditions to decide what to do next. And the textbook gets even more specific. It talks about single, double, and multiple selections, showing how things can get really complex.
Wow. So it's like building a choose-your-own-adventure game, but for computers.
Exactly. And then there's repetition control. It's all about automating things that happen over and over again using loops. They've got this really fun example in the book Chanting Merdeka.
Oh yeah, merdeka, merdeka, merdeka. That's independence in Malay, right?
Right, and they use that to illustrate a for-r loop, which repeats something a set number of times.
Yeah.
It's such a clever way to show how loops can simplify things.
Yeah. Instead of writing the same instruction a bunch of times, you just use a loop. Super efficient.
Exactly. And the book goes into other types of loops too, like while and repeat until. Each one has its own special use, depending on what you're trying to do.
It's wild how these little concepts are like the backbone of all these complicated technologies we use every day.
It really is. But just like anything complex, sometimes things go wrong. Which brings us to debugging.
Debugging. That sounds kind of like what you do when you find ants in your kitchen.
Well, it's similar in a way. It's about finding and fixing errors in the code. And the textbook uses this hilarious example to explain it.
Wait, are you talking about the one where the algorithm tells a student to get dressed in the wrong order, like pants over their uniform?
That's the one. It's a funny way to show how even a tiny mistake can totally mess things up. Then, the textbook introduces two main ways to debug: desk checking and step-by-step analysis.
Desk checking, is that literally sitting at a desk and checking things?
Pretty much, you basically pretend you're the computer and go through the algorithm manually using some sample data.
So, like with the grading example, you could try out different scores to make sure the algorithm gives the right grade.
Exactly. It's a really simple but effective way to catch any logical errors.
And what about step-by-step analysis? What is that?
It's basically looking at each step, like each line of code, super closely to spot any mistakes or things that don't quite add up.
It's like being a detective searching for clues.
That's a great way to put it. And just like a good detective, this method is really important to make sure the algorithm is accurate and doing what it's supposed to do.
It's amazing how those debugging techniques can be used in so many other areas of life too, not just computer stuff.
Totally. It's all about problem solving, right? Like if you're trying to fix a broken appliance.
Oh, I see what you mean. You're basically using step-by-step analysis when you check all the connections and settings, right?
Exactly. And thinking about algorithms can even help with things like planning a project.
Oh yeah, like you could use desk checking to try out different scenarios and see if your plan holds up.
It just goes to show, these concepts are really useful no matter what you're doing. They can help you approach problems in a much more organized and effective way.
Yeah, it's like this textbook is giving us a whole new way of thinking about problems, breaking them down, and coming up with solutions.
Exactly, and it really highlights how these concepts, even though they're like fundamental to computer science, they have these implications that go way beyond just coding.
It's like they're everywhere once you start looking for them, right?
Totally.
Yeah.
And that brings us to the bigger picture, like how algorithms are shaping our world, especially with all the tech around us.
It's true, algorithms are everywhere these days.
Right, and the textbook even hints at this, like with the example of ATMs.
Oh yeah, how those work is actually pretty fascinating when you think about it.
They break down how algorithms control that whole process, from checking your PN to like dispensing the cash.
It makes you wonder, like, what happens if there's a glitch in the system?
Exactly. Or even on a bigger scale, how do algorithms affect our privacy and security? These are questions we really need to be asking, especially as algorithms become more and more advanced.
It's true, they're kind of making big decisions these days.
Right. Think about self-driving cars, for example.
Oh yeah, that's a whole other level.
You've got these algorithms making split-second decisions that could literally be life or death. It's a lot of responsibility.
It really makes you think about the ethics of it all.
Absolutely. As algorithms take on these bigger roles, we need to be really careful about potential biases, and make sure they're being used ethically. Even though this textbook is just an introduction, it definitely gets you thinking about these important questions.
It's like it's giving us the tools to understand not just how algorithms work, but also how they might shape our future. Pretty cool for a high school textbook, right?
Totally. It's empowering us to be part of the conversation, not just passive users of technology.
So as we wrap up this deep dive, what's the one big thing you hope our listeners take away from all this?
That's a good question. I think the main takeaway is that algorithms are incredibly powerful tools. They can do amazing things, but like any tool, they can be used in ways that are both good and, well, not so good.
So it's all about being informed and aware.
Exactly. It's about approaching algorithms with both curiosity and a healthy dose of critical thinking. Don't be afraid to ask questions and learn more.
I love that. It's not just about becoming a programmer, it's about being an informed citizen in a world that's increasingly driven by these, invisible forces.
Yeah. Couldn't have said it better myself.
Well, that's it for this deep dive into the world of algorithms. We hope you enjoyed it. Until next time.
See you then.